Hi, here we'll discuss about a project design of a hardware efficient approximate force to compressor for multiplications in image processing. Here, digital multipliers are essential in many applications such as digital signal processing, communication systems and embedded computing, where the fast and energy efficient arithmetic is highly desirable. The systems benefits from lower power consumptions and smaller hardware resources and faster response, but the conventional multiplier faces disadvantages such as a high area delay due to the complex partial product detection. To address these problems, the approximate compressors have been widely used a trade-off between efficiency and accuracy. So here the existing approximate design such as a AO22 based compressors from this paper achieves a smaller gate count but introduced a significant error distance which limit their use in a practical arithmetic model. So in this work we focus on the design of the novel AO33 based approximate force to compressors that reduces the logic complexity while also minimizing the computational error compared to the earlier approximate force to compressor. Compared to this conventional exact compressors that requires 10 logic gate, and the existing AO22 designs reduces the count of 6 gates, while the proposed AO33 gate designs using a 7 gate but achieves a low error than AO22. The novelty which makes it more suitable for the error tolerant arithmetic model, offering a better balance between a hardware cost and accuracy. To verify this design, an 8x8 multiplier was developed using a proposed AO33 compressors along with the exact method and also for AO22 based architecture. For comparisons, the design were written in Verilog HDL and simulated in Modelism for functional verification and synthesized on Xilinx platforms to evaluate performance. The results confirms improvement in error rate and normalized mean error distance and mean relative error distance, along with efficient hardware metrics such as LUT utilization, slice registers and delay and power. Now we can verify the paper. So this paper is fully designed for the approximate force to compressor for multiplications. Here in this paper they are already proved with the approximate force to compressors which using a 8x8 multiplications and also compared the error analysis of NMED, MRED, ER. Okay, so this kind of errors, and they are already proved with this work in a image processing with the image smoothing method, and they compared with the PSNR and SSIM also, but we are not yet compared that PSNR SSIMs. We are not developed the image processing. We plan to improve this multiplications compressors, okay, and we plan to reduce the number of errors in the multiplications. Okay, so here the figure 2 architectures, they are given a schematic of proposed approximate compressors, so which using for AO22 architectures. Okay, so here also they will be developed with the OR gate method. Okay, but in this architecture it will be take more error noises compared to the exact method. Okay, we plan to prove this work to modified with the AO33 architectures. It will become with a very more accurate compared to the exact method. Okay, so here this is a truth table for this architecture of the AO22 and AO33 and exact method. Here the sum value it will be come with same, okay, but in the carry value it will be take approximations for this work. Okay, so in this work AO22 and AO33 you can compare it. The AO33 it will be come with more accurate and AO22 it will become with a more error. Okay, so by this way we utilize this AO33 architectures and we developed the novelty multiplier architectures. Okay, that will be proved with the Verilog HDL code and simulated in Modelism and synthesized in Xilinx Vertex 5PG. So this is a test bench of the code, and this is the top model of the code for the approximate force to AO22 method, and this is for AO33 method architecture, and this is the simulation results. Okay, so here you can analyze the error, okay, and the input and output of the multiplications. Okay, so here the data check is the original value of the multiplications, which means exact. Okay, and the product output is the error value. Okay, so in case of error 0, the data check and the product output it will become same. Okay, at the time of error it will be creating a error difference in the error value. Okay, so here error value equal to 122. So that's why we plotted the value in the graph also, and we compared this value in the error analysis. Okay, so here up to the 50 cycle of durations. Okay, so every 50 cycle will be compared the error analysis which using the error difference, total error and relative error and exact. Okay, and finally we calculate with the MED, NMED, MRED, error rate. Okay, so this kind of things. So here this is a AO22 based architecture. So here MED it will be take for 1303 and NMED equal to 8418 and MED equal to 8707. Okay, but in the proposed architecture, okay, so here this is a proposed of AO33 based architectures. So here we reduce the errors in the number of iterations of multiplication testing. Okay, so here you can analyze the error value. So here the error value will be reduced, MED equal to 938 and NMED equal to 6063 and MRED equal to 6055 and error rate equal to 66. Okay, so this value it will be compared in the comparisons table. Okay, so here this is a AO22 based architecture. So LUT slices and the RTL schematic it will be present with the multiplications part. Okay, partial product generations. Okay, and this is a compressor. Okay, so it's using a AO22 based architecture. Okay, so here also we done with the XOR gate operation. Okay, so the same method it will be handled in a AO33 method. So this is a AO33 method. Here LUT it will be increases slightly. Why? Because here we used for 7 logic gate, but in the AO22 they will be used for 6 logic gate only. But it's almost same. It will be take only 1% of LUT only compared to all the 3. Okay, so here this is a AO33 compressors and this is a exact method of this multiplications. Here we used for the exact compressor method, and this comparisons table it will be compared in the document. Okay, so here this is a comparison table for exact method AO22 and AO33. Okay, so here we can ready to give 3 different coding of this paper. Okay, so compressor based design. Separately we will be compared the exact compressors and approximate AO22 and approximate AO33. Additionally we given a 3 multipliers AO22, AO33 and exact method. Okay, and we written an abstract document for this project. Okay, so here this is an abstract document. So title, base paper abstract, objective, improvement and the related notes of this project. Okay, existing systems, advantages, disadvantages and literature review. Okay, finally references. Okay, thank you.
Visit our website today, explore our latest research projects, and get started on your journey to innovation. Join NXFE Innovation, shaping your future for VLSI research.